Two angles of a triangle measure 45 and 105 degrees. If the side of the triangle opposite the 105-degree angle measures 12 units, then what is the area of the triangle? Now here, I can obviously draw a picture to see, a 45 degree and 105 degrees. That means it's probably going to be, let's see, something like this. And this will be our 45-degree angle. And this up here will be our 105-degree angle. Now, we also know that the side opposite the 105-degree angle, which opposite that is 12 units, which means this side down here is 12 units. Now, if you want the area, you need the base, and the base here we already have. And then you need the height. And then when you use this height, or when you draw that height, we can see that cuts our 105-degree angle into chunks. One chunk over here is, a 45, 90, which means you need a 45, 90 triangle. And here, we'll then just have 105 minus 45, which is 60 degrees. And that means that since this is also a right angle, that's a 60, 90, 30, 60, 90 triangle. And that kind of helps us here, because if we assign a variable for what we want here, which is basically the height, then we can figure out that since this is a 45 degree triangle, a 45, 90 triangle, that means this is also x, and then this whole big thing over here, that is, this little x over here is basically the short leg of that 30, 60, 90 triangle, and then the rest of that, the long leg, is always x times root 3. Draw that back in. Which means now, if these two pieces, x and x root 3, make up the 12, then we can write an equation. X plus x root 3 equals 12. Now x is obviously just 1x. Also factoring this, you get x times, x times 1 plus root 3 equals 12. Now dividing by 1 plus root 3, see that x is 12 over 1 plus root 3. Now, this may look like our altitude, but sometimes, these people, just go nuts, oh my gosh, I'm dividing by a square root, and then they hate that square root so much, they just have to get rid of it. So, they said, we're gonna make up a whole thing called rationalizing it, so that instead of dividing by a square root, I'll divide by a rational number. I think what they really want is an integer down the right, because they would probably have to divide by 3 better than to divide by 0.5958 and so on. So they should probably call it integralizing something, but whatever, it's their game. So here, to rationalize our denominator, because now we have a square root, right? And the way to get rid of square roots, or at least to turn square roots into whole numbers / rational numbers, if you have here square root 3, you usually just square that to get 3, which is a rational number. But the problem with here is if you just square this like this, but what you're going to get is a 1 times 1, which is 1, so far so good. But then you get a 1 times root 3, which is another root 3. And then root 3 times 1 is another root 3, and then root 3 times root 3 is just 3, which means he got rid of one of the root 3's, but then 2 more root 3's came out, which means that squaring this thing down here doesn't work. Which means really, instead of squaring this whole thing, you want to square the 1 and then square the root 3 independently. So instead of squaring the whole thing, you want to square them like separately, or some way to do it separately. But then that kind of reminds us two different roots, two different squares, a squared and b squared. That kind of reminds us of a squared minus b squared is a plus b times a minus b, which means we can do the same thing here, right? Because it's like here we have the a plus b. X is, we have the a plus b here, and then we're going to multiply by a minus b and a minus b. And of course, you can't multiply by just this alone. You have to multiply by a very strategic one, like that. Which means now, after that, well, a squared, 1 minus b squared, 3. I have to write that in the denominator. And then 12 times 1 minus root 3. So now we have successfully rationalized this denominator. And I don't understand why they want to rationalize it, because, well, most of the time, when you rationalize it, there's still that same square root up there on the numerator. So that fraction technically still has that square root. So how come this is okay, but this isn't? But whatever. Well, if this, 1 minus root is just -2. -2 goes into 12. -6 times, which means, that means our x, which is our height, is -6 times 1 minus root 3. -6 times 1 minus root 3. So if this is our height, then you need a base, which we already know, right? Times 12. And then divide by 2. Base times height divided by 2. Only here it's height times base divided by 2. But that does not matter, since 2 and the 12 cancel. And it gives us 6. -6 times 6 is a -36 times 1 minus root 3 as our answer.